好，那我们就准备开始吧。然后我们今天是呃正式课的最后一节课，然后大家就每个组应该是有半个小时可以来 present 一下你们的项目。然后这个项目呢，最主要就是讲清楚几个事情，就是它解决什么问题，然后你们用了什么方法。然后在过程当中有碰到什么样的一些困难，然后你们是怎么解决的，然后你们怎么来量化你们解决的好还是不好，然后最后就是一个你们从中学到了些什么，所以大概就是这几个方面。那我们就先从Jane 你们组开始，你说 Jenny 会来 share，
可以听到我说话吗？可以
可以。
听到我说话吗？可以。哦，我在找那个 share button 在哪里呢？不是为什么这个 Zoom 和刚才那个 Zoom 不一样的感觉？呃，那个老师，要不你能发一个那个 meeting 的 code 吗？我可以用我的 Zoom app 打开，就好操作一些。
好，你要我发到哪？
发到那个那个微信里边。
好，我已经
OK，
发到第5期那个里头面了。
哦，meeting ID，对，你发了一个链接，然后有它那个 code 嘛，就是 meeting passcode。
Meeting passcode 是吗？好，
啊。
我找一下啊。
对，我这个这样的话就事儿好弄一些。我这个为什么就是在那个 Zoom 里面 copy 那个
Copy
invite
invitation 是
link，
吧？
对，就里边就都有。
哎，我也是这个呀。再看一下啊，看有没有。
啊，
哎，咋就没有呢？
哦，他找到了。等一下
这是 Meeting ID 吗？
啊，在这 passcode 应该是可以。
对，Jenny，我发到微
当然，
信里边了。
我进来了。
好，
现在可以听到吗
我搞了一个大的，全的。
？OK，and alright, the meeting is
没看
recorded。
到你 share screen。
OK，嗯
哦，现在有了。
，alright，
OK，好，
是我
好的。
们的，right，对，go ahead。建华在吗
在，好，我们开始。
？OK，要不对，你来开始。
Yeah, our group did a rag is based on the customer assistant. The problem we want to solve is when user is search item on the platform, usually is give a lot of choice. And for each choice, I think customers don't have that much time to check the product description, the review, all this information. So it's take a long time for the customer to find the desired item. So we want to build a chatbot. Next slide, like the Amazon, the referrals, so that it can help the users to use their descriptions to personalize the recommendation, so the customer can get the instant information. Then it's help the customer save the time. So it's help to increase the also increase the business the sales.
To build this kind of system, the major technique we use are the rack together with the large language model. And here are the major components we are using. So we start with getting a lot of product information from the which is text-based documents, and then we did some data cleaning and splitting for those text, and then we you make them into small chunks. And after that, we using the embedding model to do the sentence-based embedding. And here is the model we are using on the right about that details for the embedding. After that, we get the vector database, and we use Python or Face to store those vector database for further retrieval.
What kind of tags are you using here?
So the text are open source information from Amazon. So the details for that data source we will introduce later. Yes.
Okay.
Yeah, it's something about the product information. Yeah. And then after that, when the query was given by the clients, by the customer, we will firstly embedding those query by still using those embedding sentence transformer embedding model. And then we will do a retrieval based on the embedded information, go through those to find out to do a similarity search to find out the relative documents. And those relative documents could be used as the input for the large language model for us to search for the answer. And then we will return the answer as the personalized recommendation. So yeah, that's the basic major components of our system.
Okay, so our data is from Hugging Face. This is the 2023 Amazon product information. And so we didn't do any like web scripting or web crawler to retrieve the data. We just like directly download the data. So the data has like a 15 columns, and you can see from the left-hand side, each column represents some information about each product. For example, column 2 has the title of the product, and 3 have some detailed description about the product, and the 4 is represent the file name represent the category of the product. And there are a few more informations like a category, store, and average rating numbers, price, features, details, and also image. So overall, the data has about 117,000 products. And for our training model, we only use the product related to the baby. So you can see overall, we have 1,263 products. And to improve our like a embedding context. So we basically did a combination. We generate a new column which is called combined text. And this combined text column included information like a title, description, and rating price, and so on. And furthermore, we did a simple like we count the words in each combined text for each product. So you can see from this bar plot. And so for most of the products which have the description or combined text has about 100 to about 600 words. And this bar graph, which is important for later on how to help us to define or to decide how we are going to trunk our text. So like some of team may use the word to do the trunking, and like me, I did like a character. So yeah, we will have a detailed information later. Okay.
You further chunk the text into, you mean one line of combined text into multiple.
So what I did is like for each product, I just use description for embedding for my my project. So basically I increase the number of character to about like 3,500, something like that. So then each product description was embedded in one vector. But like for Jenny or other group member, they use different algorithm, like they trunk to small piece, I guess.
Okay. Because I see that you have like a 1,000 words, 1,200 words maximum, right? So you can convert that into tokens. So you can multiply multiply it by a factor of like 2 to 3, but it's still within like a 4,000. So seems like that most of the embedding models should be able to handle it without truncation. Right.
Yeah, that's right. That's right. So we're the next we're talking about exactly what as you said. So we use chunking by sentence. So I increase the number of sentence in each chunk. So turn out that after you do all the chunking, you basically didn't chunk anything, and each product have one chunk. So that this is a way to even we go through the chunking process, but we didn't actually really chunk anything. And then we put the chunks into embedding, this embedding model. And then so this is the flow to build the vector store. And then we save it to local face vector store, and then reload the vector store when we need to use it. And then from there we start to build our app. And then when the query come in, we embed the query with the same model and do a retrieval to return top 5 chunks. This will, since we said the each chunk represents a product, because we didn't really chunk any product apart. And so this will represent the top 5 products that are most relevant to the query. And with this flow, we wrap this into our kind of like search, simple search app. And then we have the query and the retrieved chunks, and we combine that into the prompt and then go through the GPT model to generate answer. And with the query and the answer, we build this as a chatbot app. And once you go through several rounds of this, you're going to have conversation history. And we summarize the history with the GPT model into a format, say what we think the user right now is mostly interested in, and then embed that with the same model, and then do another retrieval from the vector store, return another top 5 chunks. This will represent the recommendations or the recommendation of products we think the user is interested based on the analyze the conversation history. And then we wrap this into a recommendation session in our app. And then 1 second, let me get the video to show the demo. Next, I
I'm not
will.
sure
Sorry.
about your
Yeah.
interest, how your interest in embedding enters into your top 5.
Sorry, what do you say?
Yeah, so you can extract some interest for this customer
Yeah.
from here, right?
Yeah.
And the top 5 you are trying to retrieve. For example, okay, let's assume that each chunk is one
Yeah.
item here, the top 5.
Yeah.
And you can select the top 5 chunk.
Yeah.
And you have a query, and
Yeah.
you directly use that to retrieve the top 5. So that is one way. And
Yes.
another way that you summarize the history and use the interest embedding to retrieve the top 5. So you have 2 ways to retrieve the
Yes.
top 5, right?
Yes, that's
Okay.
right. The
Okay.
idea, yeah, that's exactly right. The idea is that, so first, let's say where the query is only, let's say, ask about a moisturizer, and the retrieve will be moisturizers. But if we do a chat, keep doing back and forth, do the query and answer, and if we save that, maybe the customer ask about the moisture first, and then after that move on, the user move on to like a diaper. And then we will summarize the whole conversation here, and then we can do the prompt here to make sure to let the model output what the customer is mostly interested at the present moment, the current moment, and then we'll just embed that and then retrieve it. So for the demo, we can see actually the top 5. It could be a combination of moisturizer and diaper. So based on what the customer asked about, and they think the system can think that, okay, now you're interested in buying a moisturizer. You also sound like you're also interested in looking at some diapers, and then they will they will put that all together and do a retrieval here. So this retrieval is a little bit different than that. This is only on the single query, and this will be based on the history.
Okay, sounds great.
Yeah. All right, let's get the video out. All right. Video, yeah.
So if the new query is something the customer didn't buy in the past, it's not in the history, then will your final top 5 not include the product directly related to the query?
Sorry, can you say one more time? Can you say one more time? How's I'm doing this?
Sorry.
Yeah.
So if the customer is submit a query that is something not in his purchase history, yeah,
Yes.
then your final top 5 becomes
Yeah.
something totally irrelevant to the query, or it will be a combination of his query and something like irrelevant to his query, but coming from history.
It's going to be so the last question take a higher priority. The last query. So we have the history. We also have the last question have a higher priority. So if the user asks a lot of questions, let's say different products, moistures, toys, and diapers, and the last one, even the diaper question is only one, and then but the last diaper question could take a more priority because that's the most present moment.
Okay.
Yeah. And this is we build this as a dynamic recommendation. So it's going to refresh the recommendation when you do the chat. But let's look at this. So this is the little streamlet we put together. And then let's start with the queries. Moisturizer.
Okay, you have 3 modes, right? Search, recommendation, and chat, and you are showing chat.
Right now we're showing chat, yeah. Because search is quite straightforward. This is one simple retrieval.
Oh, it's a multi-round. Wow, that's awesome. Okay. So now can you explain what is happening in the back end?
Oh yeah, sure. So yes. So for the first query, ask, can you recommend a moisture? And then this is just simple. We just start this. So this is a single query, and this is going to be saved into the conversation history. And the answer is also going to be saved in the conversation history. And then this is what happened at the back end. And so basically every time any new input here, all this together, all this will be saved in the history. And then the last query, when we do the recommendation, when we do this recommendation on this session, the last query always take a higher priority. But all this, everything happened here is going to be saved in the conversation history.
Okay, so right now you just recommend the top 1, right? You just recommend.
Yeah, for the chat, because I said I recommend a moisture. Now here I said I recommend some toys, so they give you 2. But if you said recommend some moistures, they might give you whatever, more than 1. So the query here actually make a difference. But the chat, so with the chat, it will retrieve 5 documents, 5 products. But if you say 1, it's going to give you, I assume, the highest relevant one. And if you say, like say some, they might give you 2 or 3 or up to 5, I would say.
How do you rank the items based on
Um,
similarities?
yeah, that's it. Yeah, based on face similarity right now, it's pretty naive. We didn't do any more details there.
Okay.
First I tried to rank that. So I tried, let's say for example, this one. This is the answer. And then based on for this one and this answer, we did a retrieval for 5 documents. And I tried to do another similarity between this one and the 5 documents and to see which one has the highest similarity and locate that document. I did that before, but it does make the whole thing really slow.
Mm-hmm.
Yeah. So right now, we're not doing any of that right now. So we'll just assume that this is this one is from the first or the most similar one, but there's more details to look into there to have better control.
Mm-hmm.
Yeah. Okay.
Okay. So you recommend the toys. Okay.
Yeah, recommended the first one is toys. And some slide. So the last question always take a higher priority. And if you go back
When you
here, if
say
you
take a higher priority, you mean you did some ranking?
yeah,
Or
yeah. So for the prompt, when we summarize this history, and then you put that in the sorry, when you read the I will say when I summarize the history and write the prompt to go to the GPT model, you can prompt engineer and say that based on the history and the last question, can you please recommend what the user is mostly interested at the present moment? So that's going to help to make the last question have a higher priority when they do recommendations or when they do retrieval.
oh, so your recommendation is prompting the large language model.
Yeah. Yes, yes, yes. Oh, sorry. No, the recommendation, let's go back. Let me explain this way. So the chat here is retrieval is the retrieval process. And then the chat history was processed with the large language model, with the GPT model. When I process the chat history, I prompt in a way that the last piece of history will have a higher priority. So when the the GPT model summarize this, and then they can summarize in a way that they think based on this and the last question, the customer is interested in toys at the present moment.
Oh, okay. And then
Yeah.
you embed this.
Embed that and back to embedding and retrieve from the vector store from there to generate the recommendations.
Okay.
Yeah. All right. So before last recommendation is mostly toys. If we go back to the moisturizer again, let's say, can you suggest something? To this. This is the first moisturizer they recommend. So now the last question is about moisturizer. And if we go back to recommendation, we can see it. Okay, is it this? Just follow up chat to see if we get information.
Can I ask a question here? I
Yeah,
noticed
sure.
that there is a sum up and sum down over there. So how does that coming into your retrieval process? The sum up and sum down symbol.
Right now it's just a show. This is the future work. We need to really link this into our modeling. Right now it's not. It's just to show that this future work we can include this information into the recommendation input. Yes. We don't
Yes.
have this function right now. It's just the buttons. Good question. So now, because we went back to moisturizer, now the first recommended one is the moisturizer. And the chest rub is also a moisturizer. And then, so this is the search. Search is simple. So it's a baby diaper. All right, and then you can add some more, say less than.
So when you apply a filter in the query, how does it work?
This is a little bit like so because when we put the information into embedding, we did include the price, and so this is a basically straightforward retrieval with the similarity. So we basically embed this thing and then a retrieval from the vector store directly. We didn't actually use the metadata, but we just used the embedding.
Okay.
Yeah, and you can see from here that price is now less than $20. So something is wrong here. It's a diaper, but it's not it's less than it's more than $20. So there's some room to improve there or to have better control.
Because when you are doing similarity retrieval,
Yeah.
or retrieval, it does not apply any filter, right?
Yeah. No,
So
it's not filter. It's language based. Yeah, it's not filter.
yeah, what do you mean by language
Oh,
based?
language based. I thought a filter is more like a logic. Let's say if we put a filter in, the logic is this let's say less than 5. So you actually compare everything less than 5 or less than 10. So basically you do a SQL. And then for the language based, I think it's more looking for a diaper less than $20. So basically they treat that as a language. I don't even know if they really remember, they really understand that 20 is a number. You can do calculations there. That's what I'm feeling. But because we embedded the price into our vector store, and the number 20 number is still there, I think, and that's how it can get the result back mostly, right? But there's one that is almost $40 instead of less than $20.
So you mean that it's somewhat implemented,
Yeah.
even perfect.
Yes, that's what I mean. Most of I tried a lot of these cases. Most of them are right. Let's say, for example, if I look at say which of all these suggested products is the cheapest one, and then so it can give you a comparison. Say this product is the cheapest one at this price. So most of the task is fine, but once in a while it is not.
Okay. So do I
Yeah,
understand it correctly? So you
yeah,
retrieved 5 using a query, and
yeah.
then you feed the top 5 into the large language model, and the large language model can apply can try to understand your query and retrieve the most appropriate items from your input top 5. Is that correct?
So this is the workflow again. So this is the query. And then for the search, the top two, the top here is the search. Can I use let's see here. So I can do this. So this is the search. How can I add it? So from here to here, this is the search. This is one single straight retrieval. And then if you, for the recommendation, it goes around. So the, this here is a retrieval, but the difference is that once we do a query and answers several rounds, the history is going, the history goes through a large language model to summarize that into the current interest. And then we use this GPT generated interest to do a retrieval from the vector store and get the recommendation.
And
Yeah.
and you have got the top 5, right?
Yeah, the top 5 here, yes.
And then you need to synthesize it into a answer.
Oh, yeah. For the recommendation, I think the recommendation this is directly is not a this is the sorry, this does not go to another GPT file anymore. This is directly output as a table of products.
Oh, okay.
Yeah, yeah. The only generative answer here is here for the chat query to answer. Yeah.
So I guess that is still pretty. Yeah, I don't know how the filter is applied in the embedding. So maybe it works. Yeah, for some.
Yeah, I feel GPT is getting smart. Before I feel like I'm not confident doing the numbers there, but once we tried it, it's surprisingly better than I thought. So we did it this way. Before I tried this way, I was doing this way. So I have the query and the answer and I save a history. I'm going to use the history to do the same thing in interest. But the thing is, after I do the interest, sorry, I guess the filter mostly applied to the query. So when I do the query, if I say less than $20, and then how do you find that? So you do the query, you retrieve the top 5 moisture, let's say moisture less than $20, but they cannot read the $20. So they can read moisture, and the top 5 will be moistures. And then from there to here, I generate an answer. And then I'll measure the answer back. I'll how to say, retrieve the answer back from here to see which document, exactly document of this 5 documents used to generate this answer. And after I locate that document, which is also the product, I can have access to the metadata of that product. And the metadata will have the numbers. And from the numbers there, and do a filter. I tried that way, but it make the whole thing very slow. ChatGPT is smarter compared to speed versus accuracy. ChatGPT right now so far looks like mostly are fine. If you go that way, the whole app when you do the chat is very slow. It'll take a much longer time to generate an answer.
Yes,
Yeah.
agree.
Yeah. Okay, so this is our so we did most of the, I guess I spent most of the energy try to put this together. So and this is our product so far. I will pass any more questions, or I can pass to Celine talk about evaluation.
Okay.
Okay. All right. Yeah. Let's go back to presentation. All right. 张老师在吗？
哦，sorry，又忘了开了。那个
啊
时间关系我就用中文讲了啊。这个 evaluation，我们其实我没有做什么 evaluation，就是从理论上讲，这章都是理论上讲的，就是其实可以 experiment with a lot of different things，and Jenny 也 experimented，但是我们没有把它就是跟这个 evaluation 这个东西有机的，就是结合起来做一个 iteration。然后呢，这个里面咱们课上讲的有好多 type of metrics 啊，左边儿就是都是课上面的。我这个，然后后面我会授一个 Ragas 的这个 performance 的 metric 啊然后有一个 question，其实就是我也是问大家，就是这个 user engagement，我觉得好像其实还是最重要的一个吧。然后我不知道从 Ragas 上面和它和这个 user engagement 有没有 correlation。然后最后 business metric 我们现在没有办法去 evaluate。然后呢，就是
engagement，你除非有它的整个 browsing 的 history，要不然还是挺难弄的啊。
browsing
你
history，
是说
但是刚
它直接
才那个 sum up sum down 它是应该可以的。
对。
你说那一种 ，OK，好。
对，但是 somehow 呀，我觉得 somehow 有可能有些 bias，就是说你可能只有看见它很不好的时候，对，但是呀，你就说 user engagement 其实也是， 就是说通过 user behavior 来算，对吧？
对，因为是这样子，就是不会每个人都会去点那个东西，而且绝大部
啊，
分人是不点，对吧？
对，
所以除
嗯
非除非就很少一部分人会看到这个东西，所以
嗯
我们一般就是，因为能记录下来每个人他在你每个页面停留多少时间，然后他接下来干了每一件事情，你其实都有记录。
嗯
对，所以这个东西我们是可以根据这个东西你能看出来它的 engagement 的。
这个浏览的时间，
对对，
嗯
浏览的时间，然后他是不是 abandon 了这个 session 的
嗯，
这个是能够测出来的。
对，
对对，
好的，对
在这个地方，这个就可能信息不够。
OK OK，所以你们会用一些 user behavior，
对对
user behavior，OK，
对，
嗯，然后 OK，对。然后右边的话就是说，对，然后后来我就是，而且我觉得这个 user query set of queries 很重要。如果你就是在 build 这个 system，咱们作为 developer 的话，然后我就问 ChatGPT 说，evaluate shopping bot 应该问一些什么样的问题，然后他给了我7个 category 的问题，然后呢，就大概在这儿就是很快的授一下，比如说 basic retrieval 啦，comparison 啊，然后比较 complex，就是这个上面的刚才 Jenny 做的这个 bot 基本上都可以 handle 啊，但是我没有去 evaluate，这有4个 category 现在是可以的咱们再看看下面啊。
我这
然后下面的话，这可能就比较复杂一些。不知道 Rufus 现在可不可以做到，就是 personalization 啦，customer support 啦，这个 ambiguity 和 requesting clarification 这些，可能就是刚才授的这个暂时还不能做，但是就是说 ChatGPT 会给我这7个 category 来 evaluate shopping bot 的 performance，然后
嗯，
这看你们有没有什么嗯
不错，挺
feedback。
有挺有意思。
嗯。
我还没有研究过 query 的分布呢。就比如说你这7类到底每一类大概有多少，是吧？这个我还没研究过。
对，其实我觉得这个东西要写一整套很好的 query，可以把这个 chatbot 整个比较很 comprehensive 的 evaluate，我觉得很不容易。然
是
后我们下面有一个小 example 啊，刚好我这个 example 就是有点儿正好是擦边儿的，为什么呢？因为我们就是其实是最后几天把这个chatbot 原来是就是最后几天我们 focus on baby products，所以呢我就想当然的问了一堆关于 diaper 的问题。但是正好这个 dataset 里面，后来我在 evaluation 的过程中才发现，其实这个 dataset 里面没有 diaper。对，然后呢，嗯，唯一的一个 diaper 其实就是第二行的这个，所以就是说，在这个 dataset 没有 diaper 的情况下，它这5个问题回答的还不错。我这个5个问题就是有点根据刚才 ChatGPT 那个什么的，那个 suggested，比如一个 basic 的，然后还有一个是问 dataset 里面有什么，就是第二个问题，这个的确这个 dataset 里面只有这一个 diaper，就是这个 Pampers。叫做training underwear，就是乍一看是 underwear，但事实上它是一个 diaper，所以它其实答的还是不错的。然后第一个呢，这个里面怎么说我就不太清楚这些第一个它就
它这个就是你们数据库里头是没有这个东西。
对，所以就是说这种问题的话，比如说 Amazon 不卖某种东西，那么它就要推荐一些就是不是很那什么的。呃。
我们不会的，我们每一个商品推荐出来都会 link 到它的一个网页上去，然后会让你看到它的一个缩略图，所以不会出现这种 这种就
它
是
是这样子，它是这个数据库里边是有这个 product，但是
对，
没
这你看
有这
他推荐了
个直接
3个，他推荐了
对
3个，
对。
对，然后但是你看这个 Ragas 的分儿就的确就比较低，
嗯，OK，有意思。
对吧？
他的意思就是说没有 directly diaper，但是有这个类似的 diaper 的东西，他还是能找出来，
对，
但是他
其实
这个就比较
是
低。对，
disposable diaper liner，yeah， what is diaper liner？其实是还是比较接近的，但是它的 Ragas 分儿的确也比较低，因为它其实，你去 Amazon 上面的话，它就是真的把 diaper 给你拿出来，但是咱们这个 dataset 里面没有，然后
这三个都是有吗？是有还是没有？在你们的数据库里头？
这
在
3个数据
数据库里
库里是有，
是有的，
哦，
对，
这
是有的。
三个都是有的。OK，OK，OK。
对，是有的。而且前2个可以勉强算是 diaper，第一个应该可以算是 diaper，第一个是 diaper，第2个勉强算是 diaper，第3个就不是 diaper，就是他推荐的第1行里面推荐的这3个东西。
那这也 make sense 啊。
对
那只是挑 top 几的这个 most similar，就
，yeah yeah，对，然后第2行其实是答的不错的，分儿也比较高。然后第3行呢，我其实问了 ChatGPT 2次，它的答案都不一样。第一次是纯粹是 ChatGPT 自己，就是根据它的 knowledge，然后给我答的就还不错。比如说 Earth Best，还有就是几个我知道的这个 organic 的 diaper，但是第2次再问呢，他就去这个 dataset 里面去搜这些东西。你看 Calvin Klein 这根本就不是 diaper，对吧？就是它这几个里面就是说它就不是 diaper 了，所以它这个，但是从从这个 Ragas 的分数上来讲，我觉得看不太出来。这个 faithfulness 是指它跟 retrieve context 的那个呀，I don't know 这个怎么 interpret。
这个 dataset 的 ground truth 是你们自己做的还是怎么得到的？
其实对我这个里面其实就没有 ground truth 了，因为大部分问题在这个 dataset 里面是没解的。
没有 ground truth，这个 Ragas 怎么算呢？它不是
Ragas 是不需要 ground truth 的，Ragas 它的特点是它不需要 ground truth。
有的 metrics 是不需要的，那它
嗯
应该是挑了一些不需要的来算了一下。
嗯，Ragas 有
它可以实际上可以用大语言模型它内部的一些东西嘛，也可以来判断一下。
对
它是说，
对，
比如说把它一个 statement 就分成很多的这些 fact，然后呢就来算你这个 facts，的实际上就 true positive false positive 的那些算了个 F1 score，好像那个东西就是这里的 faithfulness，
嗯，
它是这么弄的。
说那个好像是说他的答案和呀，嗯，然后第4行这个我是 expect 他会出这个嘛，就是说 I cannot answer this question。其实我觉得这个 answer 不错，但是呀，他的分儿肯定就比较低了，对吧？因为他不能 answer 这个 question。嗯，
这个就有点难了，这个哦，他还答的还可以啊。
你说最后这个吗？
第4个嘛。
就是最后这个是吗？
对啊，他这也还行啊，你看他这也比出来了两个。
他对我都不知道他这个东西是从哪儿来的，因为这里面 Pamper 和 Huggies 的我们的 item 还挺少的。
那个就是纯粹是大语言模型它自己 internal 的 knowledge。
Made with plant-based material. Yeah. underwear like fit.
因为它没有涉及具体商品。
其实
那要看它这个商品 description 里有没有这些类似的句子啊？
它整个就一个 diaper，而且它这个 diaper 还就是这个 Pampers。
只有一个 diaper
没有，
吗？
它有一些，对对对，是这样子的，就是说 Huggies 其实都是那种 pants，
哦，
对，Huggies 都是 pants，所以他最后，对，我觉得这个，他就开始有点儿，就是开始有点跑火车了。这个
pants 是指的那种，但也是 diaper 那种 underwear 对吧？
就是跟 diaper，也就是跟 potty training 有关系的，所以它
嗯
能被 retrieve 出来，但事实上它并不是真正的 diaper，所以，他还是忽悠了一下，应该说是，
嗯，OK，好，
对。所以说呀，呃，对我其实就是说这个，Ragas 是不是可以 detect 这个 problem？比如说这些问题，它得的分儿是不是偏低？然后我们就说，哦，OK，这些问题可能出的就不好，啊，
不过我是之前试过一下那个 Ragas，我甚至就试了 Ragas 他自己给的那个，他自己给的数据，就他自己官网上的。然后当时我就发现有一两处吧，特别明显不合理的分数。所以这个 Ragas 本身就要对它有点儿警惕性，它有
但是
可能是不对的。
对，但是就说有没有什么 alternative？哦，那就是要 ground truth 是吧？对，
有关
这 ground truth 就
也好，
很难，
好，
OK，那最后一页，就简单说一下我们的 future work，因为时间有限，我们现在能做到这里。但是后边如果要是把这个做完整的话，还应该是还有很多工作要做。比如说刚才我们说的这个 evaluation system，我们现在没有，可以建一个。然后那个 accuracy，就是说，比如说刚才问 less than $20，才出来一个40块钱的，然后怎么样去 optimize 这个 accuracy。然后我们这个数据其实是有 image 的，但是时间有限，我们没有把这个 image 弄出来，可以把这个加进去。然后还有这个 latency，就是说recommend 的时候好像是有一点点慢，现在是比以前好了，但是还是慢。然后 latency 也是要就是说 be aware what the latencies 你要是 take 太长时间generate answer 就没有人用了。然后 scale up 的话，这就是多了，就是比如说我们的input for recommendation 可以有更多的 user profile information，或者是还有是 active 的 information，或者是说scale up 也包括这个，我们可以加入更多的产品，不只是 baby 的，可以加入什么 computer 啊 whatever，然后还可以加入更多的 store，不只是 Amazon，还可以有 Walmart 这些东西。这就是 future，就是如果想做一个成熟的，我们是这样想，如果想做成熟的话，这个 scale up 的空间很大。然后另外一个就是说user more user friendly，就是说我们可以把那个刚才我们授的那个是search 和 recommendation 还有 chat 它是分开的，就是要切来切去，可以想办法把它整合到一起，然后让它更好看一些。然后online deployment 就是possible future work to finish this product and that's it. That's all we have.
很好，非常好，谢谢。我觉得做的很完整，而且做的很深入，这个非常的 impressive。而且这么短时间可以把它搞定，这我觉得，尤其是这个 flow chart，然后这写的非常清楚，然后包括说能够从 history 里面总结出来 interest，这个还挺巧妙的，就我觉得这个挺深入的，因为的确是，就我们真正做的时候，也的确就是关心这些方面，所以这个也很，这个设计非常的怎么样？
老师，这有个问题啊，就是我们在做 embedding 的时候，比如说像 price 这些数据这种，就是你是建议这种带数字的东西是放到文字里边儿一起做 embedding 吗？因为它
嗯，
后来就是embed 到 vector 之后，然后再做 similarity，这种会不会出问题？数字的话？
那些你就弄 filter 就好了，用 filter metadata 那样，然后做 filter 就能够很准确的把它们搞出来。
如果说做那个 metadata 的话，后面比如说，你问一个问题，他给你推荐了5个产品，对吧？ 然后你的产品信息相当于是在 metadata 里边儿，但是后来你要继续问这个chatbot 问他关于某个产品更细节的东西的时候，这个你没有做 embedding 的话，
就是你在 retrieval 那一步就要去 filter 它。
对，
在 embedding 不是在 retrieval 那一步，在前面你把这个 metadata 做好，比如其中有一项就叫 price，你把它的 exact
对。
price 就放在那一项，然后那个问的时候，如果说什么20刀以下的，那应该让它去生成一个去 search 这
对
个某一类东西 price 在20刀以下，只有这种才 retrieval。
就是说
对，
模型它是可以这个生成这个 filter 吗？你是不是要让它去？
一个 query，就就如果你真的是要做，然后就要做的就很准的话，你是需要加一个 text to query 的。
嗯，对对对，make sense。
因为你实际上你大部分的 query，你其实就是那几个 filter 一加就基本上可以了嘛。一个是 category，然后一个是 price，然后还有一些可能有些 tag 之类的。
你你的
然后
你的意思是说，就不用把这些做 embedding，就直接让它那个 chatbot generate 那个 answer 的时候，直接就是去metadata 里面取了这些信息，然后给你 generate
其实
answer
它
吗？
就是做了一个在里面做了一个
这
SQL。
个对，就直接变成一个 SQL 的一个 command。然后这样
但是像 category 这个的话，比如说
哦，我这边有，哦，我
去
这有一个 metadata 在这里边，然后其实是可以实现的，就是说，你先 locate 这个source document，然后把它的 metadata 弄出来，然后这里边就是很多数字的东西，比如说 price 啊、rating 啊这些东西，我试着做过这样的东西，然后就是可行，但是唯一的问题就是可能我做的也不够好，然后并不是所有的东西都能弄出来，而且它就是很慢。但是
对
如果要是想 control accuracy 的话，你就应该是这样子做的。对
对对
那你当时不
对
是说这个 price filter 总出问题吗？
对，就是拿那个 Meta 来做，然后我们那个时候那个时间太有限了，没弄好，所以后来就试了一个那个比较野蛮的方式，直接把它放到那个 language 里边。但现在就是说它能出来一些，但是它 accuracy 其实是比如说你今天用了这个东西，它可能有一个出错，然后明天可能没有出错，但是后天可能有5个出错，就是你没有办法控制。对。
对，
然后这个的话，如果弄好的话，应该是可以accurate 更可以控制
对
accuracy。对，
，OK，好的，谢谢，我觉得做的非常
对，
好，谢谢。
好的，谢谢谢谢。
好。